Hello, everyone. Welcome back to the show. Robert and Lucas aren't with us today. They could have not joined. So it's just going to be me and my guest for this one. Honestly, I think that's going to work in our favor because the conversation I want to have today with you is the kind of conversation that goes very well one-on-one.
Yeah.
So, for all of you back home, today I've got someone I've been wanting to sit down with for a long time. We've always had many interesting discussions offline, but I believe that the discussions and stories that we had are very interesting also to be shared online. So we have Andrei Marinica.
Hello everyone. Yeah, I've also been waiting for this for quite some time. Ever since the Momentum podcasts have begun, I was like, when is my turn coming? Well, turns out today. So yeah, it's
Yeah.
exciting.
If you've ever written a smart contract on MultiversX, you've touched his work.
Yeah, you've interacted with my art.
Yeah, so you've been building the Rust framework that most of the I believe 99% of the ecosystem.
There's, I think the only alternatives are there's a TypeScript one and there's one in Swift, but I don't know how many people have used those. So most people are writing smart contracts in Rust. That's my main work, I guess. That's been my main work. Although we'll see is just a tiny part of it.
Yeah, exactly. But before we go into VMs, frameworks, AI, formal verification, and the rest of it, I want to start somewhere. Most people who follow you and us on GitHub, and we know we have quite a few, don't know, and probably they don't expect. So you were part of a band, or you are part of a band?
I am part of a band. I actually recorded some vocals last week. So I've been in a band for a very long time. We're not active right now. Not very active. And that's mostly MultiversX's fault. There's been I haven't had time for the past 8 years to properly engage. But yeah, the band's still active. I play keyboards and vocals, and we do gothic metal and all kinds of extreme metal, and it's what I like, and I wish someday to have time to play more of.
So how serious is it? Are you going and playing in clubs or?
I used to. We had some concerts in Sibiu, also in Bucharest. We've had some fair share of activity. We haven't yet released the first album, so that's the next milestone.
Are you working?
Yes.
On it?
We are. It's been delayed 15 years or something like that. Most of the music is written. We just have to record it, and hopefully we'll have something out. And playing again, I miss playing. Yeah.
I'm very curious. Was there a clear moment when you switched the lanes toward programming, or was it the music first? And
No, music was always a side gig. I think I've started more seriously since college. I've always wanted to do it, but I'm not very talented or anything. So
at music?
And I just like it very much. So I invested a lot in it. That's the whole shtick. And I've taken singing lessons for many years and trying to play keyboard. I don't play them very well, but it's fun. I do it sometimes. And now I have a small 1-year-old daughter, and she's starting to make noises. Thank you. Starting to make noises at the piano. So I think there's somebody to continue the tradition. Yeah.
That's very nice. And I'm asking mostly because I've always thought that there was a thing, musicians, and not only, but some of the musicians keep, and this translates very well to how systems work, because you always say that they have the ear for it, and they feel by the ear if something is off, and they can tell you, okay, this is not okay, before anyone can explain. Okay, people with musical ears.
Yeah. Yeah, so that's one layer of it. Yeah, having the ear to hear when it's right and when it's wrong.
Do
I
you
think
have the
it's.
same year or the
I
same
have a
feeling
terrible
for?
ear. I have a terrible ear, but I've been trying to train it to make it better. Now I can hear a lot better than I did like 10 years ago, but it's still not great. There's a lot of people who have great ear, like from childhood, and
But
I'm a bit jealous of them. Uh,
do you have the same feeling for when something that shows up in the code which is off and you
Yeah,
feel
yeah.
it?
It's a kind of taste. I think it's more abstract than having the ear for it. It's like taste. Like everywhere in art, I think you also need taste in code. And there's actually a very funny meme with there's a famous producer, Rick Rubin, a guy with a huge beard,
Mm.
and there's a meme of him. It's a part of an interview. It's like, what makes him so special? As a producer. It's like, does he know music? There's like, no, absolutely no ear, no training, no nothing. Well, then what? And it's like, oh, my taste. It was very serious, like my taste and my ability to articulate what I would like. It's like, okay. And actually in it was often the meme works very well in the context of AI, because in on AI you usually
Vibe.
yeah, you vibe, you vibe with an AI, and taste is actually very important, because taste might sound like a fad, or something very abstract, but it actually can give your code direction, beyond the grueling code that we don't need to do so much anymore. The taste, the how the code should evolve. That's and good programmers always notice taste. When you're reading somebody else's code, you notice if it was written tastefully or not. Um, yeah, it's fun. The way they say, sometimes in these action movies with swordmen, they're like, oh, you don't know somebody until you've dueled with them, with a
Yeah.
sword. And I think it's something similar with coders. You don't know a person truly as a coder until you've seen their code, and you're like, oh, how tastefully
Yeah.
was it written?
Insightful. Yeah, but I'm very happy that you mentioned it, because for me, also the best engineers and programmers I've worked with all have this sort of discipline. So they were serious about something else first, be it music, be it mathematics, photography, or I don't know, chess, whatever.
Yeah.
Um, it's like the brain needed to learn how to focus very powerful on
Yeah.
something,
Yeah.
and then you found code, and from
Yeah.
there everything
I think the first thing I
developed.
found was Legos.
Oh,
Yeah,
goes.
highly recommend. I was obsessed with it as a child. I think that just sort of translated.
And
Still building Legos like 30 years later. So
so you are still doing it,
no,
like,
I mean code itself is like building Legos. Yeah,
yeah.
I'm doing it with my daughter now. So yeah, that's fun.
Okay, so let's jump to the moment you joined what was then Elrond. Walk me through the scene. How big was the team? What were you doing?
Yeah, that was a fun time. It was 2018. It was late 2018. I had just met Lucian and Benny. They were very, very eager to get me on board. I couldn't believe, I had met them. Like I had been looking for such a project for years. A bit of background on myself. At that point, I had been working in many companies, all kinds of projects. At that time, I was trying to do a PhD and dropped off. But I was very interested in doing some research and being like in a startup, doing something original, something cool. And at the time, the job I was in, I was considering it like a milking cow,
Mm-hmm.
And it was it was a very nice job. I enjoyed it,
Mm.
and then it gave me enough money and enough time to do some research after it. And for the first time in my life, I was like, oh, finally a project where I can actually do the research as part of my job. Yeah, so that was cool. It was too good. It was a bit too good to be true. So I didn't enjoy full time for the first 3 months or so, and then I was like, yeah, this is it. Let's go all in, all in. And I've been all in for the past almost 8 years now. Yeah, and at the time I had no idea, of course, about blockchain. Nobody knew anything about blockchain. The team was actually kind of small. I had met Adi, and this were 2 or 3 more people in a very, very small office, tiny part of the office at the 14th floor. Yeah. Anyway, and thing is, I was the only one in the team who was not in town in CBU. I was living in Cluj at the time, and I was the only one remote, which I did not enjoy very much. It's nice. It's really nice to be in the office with everybody. But that was it, and it was also not such a problem because I was working on something completely different. At the time in blockchain was the huge. Everybody was crazy about formal verification. I had very little idea about formal verification, but it was more than zero, which most programmers had at the time that I knew, or So yeah, I was a great choice. And actually, for the first year, I tried to less than a year. I think until the summer, until August, so like 8 months. What I tried to do was build a new VM. We had nothing at the time, so when I joined the Eland project, just a second. I think these ones are falling off. There we go, much better. Right. So at the time, Elrond only had the prototype in Java, which I did review. I was working in Java. It was cool.
So your first impression on that prototype was it was cool.
Yeah, but although I didn't understand barely anything about it, but I looked at the code. Yeah, Java I was like, it's fine. Then the guys decided to switch to Go, which I happily learned like in a few days. It was actually the fastest the fastest programming language to learn. Which was cool. I don't like it anymore as much right now, but we'll get into that. And in parallel, I did something else. There was this VM out there called Yele VM, built by our partners at Runtime Verification in K framework. A VM built based on a formal specification. Really, really cool stuff. I loved it. The only problem was the only way to run it was either through some arcane stuff. Again, this was 8 years ago. In the meantime, they've improved a lot of technology. It's a lot easier to run what they built, but at the time you had to choose between like Haskell and OCaml or something. It was very difficult to integrate with Go, what we had. And I did something crazy. I was like, there was this code generator that was generating OCaml, which I did not know what. Written in Java with Scala. I did not know Scala. In K framework, which I had no idea about. And Go, which I just learned in a few days. And I decided before AI and anything, I decided just to deconstruct their code generator for OCaml and transform it into a code generator for Go, which I did. It was painfully slow. It took me months to get it to work. I broke the compiler, I seriously broke the compiler. It was generating like 200,000 lines of code per day. So there's there's an old animation with our source code. And, the rest of the team was toiling, at the main protocol. And you see, in GitHub, you see like the commits going in, the code coming in like a tree that grows like slowly. And then suddenly there's this huge thing slap on. And then again and again and again. It was like my 200,000 lines of code on top of that. And ultimately, it was too slow. I optimized like 50x or something. It was stupidly much. I did some crazy stuff to make it to work, but it was still too slow. And I'm like, okay, this is cool. It's not going to work. But what came out of that year and was very cool was, first off, was my first experience with blockchain. Then we had our foundation for the first tests that we could have because we just migrated sort of testing framework. And then a lot of ideas came from there, especially the idea to have like big numbers directly into the VM, because this Yele VM being formally verified actually had big numbers in it everywhere. And this was, I thought it was nice, no overflow problems from the very beginning. I was saying, maybe we could do that. And fourth, we realized that, so this was an interpreted language, right? There was, we were generating an interpreter basically. And interpreters are slow. For the less technical out there, the difference between an interpreter and a compiler is the interpreter will go at runtime through each instruction and execute it. So there's some overhead there. Whereas there's more overhead there. Whereas the compiler will just, at the very beginning, will look at the entire program and just translate the entire program into machine code or something, inject some, some gas, some blockchain-specific stuff, and then there's it. And then when you're running it, it's a lot faster. And from our measurements, like 10x faster to have a compiler. So that's when we said, okay, this is formally, modeled nice, but we can't have the fastest blockchain on the planet and the slowest VM. So we decided to move to WebAssembly, and the rest is history. And we've been very happy with WebAssembly and Wasmer. So Wasmer is this execution engine, which became then in autumn, winter of 2019, became like the basis of our VM. And I remember it was January. I was I had been 1 year full time doing all these experiments. And then we're like, okay, cool. Now we have a VM. Let's run some contracts on it. And what do you do to write contracts to WebAssembly? There were like two good options. One was C, plain old good old C, and the other one was Rust. We did some contracts in C, but it's C, it's old. It's very, it was difficult to write code in C. It was good for testing, but that was kind of it. And then it was Rust. And then we were looking around and we were like, okay, who knows Rust? Nobody. Okay. Who wants to learn Rust? It was just me. So I learned Rust. And after the experience in the previous year with Go, I was like, oh, I learned Go in 3 days. I'm so good. I'm sure I'm going to learn Rust. Okay, it's a bit hard. I have to take me a week. Oh, no. Rust took me a few months, and I'm still learning Rust. So Rust is a bit rougher. But I don't want to go back to Go. It's a much better language. It's far from perfect. I have a lot of criticism to Rust, out of scope for this podcast. But it's nice. It's a good language, and and then started building more and more on top of it. I remember like last year, I looked at how the framework was looking like back then at the beginning. It was interesting. It was very heavy on macros and code generation. Now it's so much tastier. So much more tasteful. It was not in very good taste at that time. We made it a lot more tasteful, in the coming year or so. And after that, actually, a framework is only as good as the stuff you can write in it. So actually, before the famous mainnet launch in 2020, half of the time I was building the framework, and half of the time I was building our very first smart contract, which was the legacy delegation contract, which it's still in use to this day. And that was rough, because every day I had to decide: do I spend some time to improve my tooling and make my life less miserable, or do I spend one day to do the stuff that I'm actually supposed to deliver, hard deadline, at the mainnet launch? So I was jungling with the two, and that was the first experience writing smart contracts, and that's that's how it went. It was very fun, very intense. Very, very intense first 2 years or so.
So going the Rust way, becoming a Rustacean, or what's the
Rustacean?
Rustacean.
It's a joke on crabs, because there's actually it's crustaceans, right?
Yeah, exactly.
They're all crustaceans. So they did the crab thing way before OpenClaw. When I saw OpenClaw with all the crabs and stuff, like, man, come on, you're ripping off. Rust has been doing this for like what, 10 years? The whole crabby thing.
You know the saying, it looks like a duck, it quacks like a duck, but it's not a duck.
It's a crab. It's
so this decision aged well, going the Rust way.
It aged really well. I mean, there was not really any other decision. Looking back, would have been nice to have everything in Rust, actually.
Also
so between Go and Rust, I think looking back, it would have been nice to have everything in Rust, for many reasons. Speed is not the most important one. Just the ecosystem is nice, and if you have the protocol, and then you have the smart contracts and the tooling, everything in the same programming language, it becomes so much easier to work with them. There's some interoperability that we have to, plus Wasmer is also in Rust. So every time, you're calling the VM, they have to go over, switch from one language to the other, go over. There's a bridge there. Anyway, but it is what it is. So that's why there are blockchains that have everything in Rust, and they have a little bit easier time than us, but but it's still fine, and all the tooling works great. So, the reason why it was not such an obvious choice, and at the time maybe it was a better choice to go for Go. Go was a bit more mature. So 10 years ago, Rust was pretty green. It still isn't fully mature. So that's the only problem with it. It's not perfect yet.
I like a lot the way how this connects to something I run into almost every time when I teach. I have this program right now with blockchain and stuff at the university, and most of the students are business and economics and financial students, not engineers. And one of the hardest things to get across to them is the fact that almost everything that looks so well now and works like a charm, like from
Yeah.
my point of view, the Rust framework helps a lot in the development of the ecosystem. And I know you will say it's not mature yet, but at some point this was a judgment call somebody made, and it looks like it was a good call back then, and
Yeah.
it aged well. But I think that there are lots of decisions that have been made back in the time. Like you, as you said, you experimented with K framework, and we will come back to
Yeah.
it, and
Yeah.
with Haskell and everything. But coming closer to today, um, I'm curious, what have these last few months? I mean, we have Supernova for a
Yeah,
few months.
Supernova. Yeah, thing is, I'm not directly involved in Supernova right now because I'm not on a protocol team. I did spend quite some months earlier this year. Yeah, earlier
Mhm.
this year we had Barnard launch, and that was actually our little bit of Supernova. It was the preparation for Supernova. We did everything beforehand
Mhm.
because we did not want to get in the way at all. Like the guys are super focused on Supernova. We wanted to take everything that is not strictly necessary off their plate. Um, so we have a strictly no interfering with Supernova policy, unless it's like critical and it screams and people are gonna lose money. We're not touching the VM or anything like that until after Supernova. Um, so right now I'm a bit of a spectator on the side, and I'm like
Mhm.
more like trying to help them out to test stuff and prepare the next steps, sort of prepare the
Mhm.
transition. So actually Barnard was a bit hectic for us, and then after Barnard was launched, then we got a sigh of relief. Everything was fine. It's like the ball moved in a different court. That being said, we have been working on testing and stuff, and of course, what's the past few months we're experiencing the AI revolution. So of course, everybody's impacted by that,
Yeah.
myself included. Of course, we all work with AI and try to figure out how to be most effective with it.
To
Um,
be very direct, how do you use AI
yeah,
on the
good
day to
question.
day?
I was like, yeah, I'm a very conservative user of AI. I really like Claude Sonnet. Um, I tried Opus as well. I just felt it was doing a bit too much and it was more than I needed. Um, the way I see it, there's like two ways to engage with AI. Like a big step AI, like
Mm.
AI guy, do me this project, make this and this and this, and then I leave it for like 13 hours and I don't look at it. Um, and I think it works well for new projects, for certain technologies, for certain things that you do. I haven't tried so much working with it as like this. And the other one is like small step, like okay, let's fix this, let's do this step, and then the next step, and then the next step, like go step by step. And this is what I've been doing for the most part. And I like this because I'm very much in control, and I
Mhm.
feel that I need to be in control at least at what I'm working on. Plus, the project is huge. What
Mhm.
we have there is absolutely huge. As a side note, so it's not just the smart contracts. We have a VM, we have a lot of tooling, we have web stuff. This is a huge thing, and you need to guide the AI agent to really understand. So first off, you can't just give the whole project to the AI
Mm.
because it's too big. And it's not, you don't need that, it doesn't need to load like 200,000 lines of code in this
Mhm.
context. When it's way too much, it doesn't need that. You need to point it to certain problems, to source files. It's very good at finding stuff once you get set it on the right course, and then solving one thing and then another thing and so on. And this way I can be in control. Otherwise, at least for what I've been working, there is a tendency for it to think it understood and try something very original. And if you leave it too long, will stray very much from the what you wanted it to do in the first place. Whereas if you go step by step, then you do this, you correct, you do this, you correct, you just course all the time.
Mhm.
So I don't know. Maybe it's not the most efficient thing, but it works for me and it gives me a lot of control. So yeah, that's the main development part. The other thing is reviews. Reviews are a different beast altogether. So all my code now goes to AI reviews, to Copilot, which is such a nitpicker. Such a nitpicker. I haven't had such brutal reviews like ever. But I love it. I love it. It's very attentive to details. It has pretty good taste. If you do something tasteless, it'll be like, man, that sounds off. That smells. I'm
That's
like,
not you.
you're right. It smells. It's like it does smell a bit. Okay, fine. And but actually, very very rarely dismiss the comments. I think they're really good. And over the past few months, I think the code quality has improved a lot. I mean, everything that's been going.
Cloud, you mean cloud quality or code quality?
Code quality. Like our code is much better now because I'm getting these reviews, and usually when I'm touching something, I'm getting these scathing reviews. Like I have to fix it. I'm also a bit of a nitpicker, so that works well in our favor.
About that, how do you pick, because you're a nitpicker, what is good from what is bad, from the suggestions and findings that AI comes with to you, let's say so?
So from the reviews, most of it is good. And I don't always agree. I rarely agree with the solution that he proposes. The Copilot proposes solutions. I don't always agree with. It's like half of the time I don't agree with what his proposal for improvements are. But the problems he notices notices are good. And then I go in and I usually choose. Yeah, okay, we're doing it. Yes, I agree this is wrong, but we're doing this my way. Other than that, we've had some hardening a few months ago. We should probably go through it again. Didn't find much because our code base is
It's good.
It's good.
You're doing a great job, yeah.
As there's different programmer personalities. There's people who like to move fast and break things, and I'm not one of those. I'm very, very attentive to details, which makes me very reliable. Like my code is very reliable usually, but I'm also a bit slower than the ones who move fast and break things. We have colleagues who like to move fast and break things. I think it's a bit of a personality trait as well, and also what your experience as a programmer has been. I've worked on a lot of projects, like horrible projects with a lot of legacy code base, and I'm traumatized by that. So I want my code to always be nice and clean because I've suffered, in this life, I've suffered a lot. If somebody has had more of the experience, like build a quick project, let's have some fun with it, like start something from scratch a lot more times, maybe they're going to be more sort of courageous. I'm paranoid. And actually, that's one of the reasons why I think blockchain works so well for me. On blockchain, it's good to be paranoid because if you move fast and break things, you might lose people's money, and it's not fun. And a lot of people lose a lot of other people's money. There was I feel like past year or so, I had been seeing less hacks and less money stolen. And this month, it's like, again, everything exploded, which I don't know, either means that people are using blockchain again more, or people are being careless again more. I don't know.
People are using AI and using blockchain using AI.
Yeah,
this is what's happening.
which is a good thing, but but you need to somehow figure out security as well. Which is not a new problem. It's an old problem. Might have been a bit accelerated by AI. So has not been solved by AI. Yeah, anyway.
I've seen this with the students, and they are copy pasting AI generated code like crazy, and they ship contracts, they ship backends, front ends, everything. But this is subtly wrong. I mean,
well, actually, you could argue that like a year ago, people were copy pasting directly from Stack Overflow. Maybe not so much on blockchain because there was not so much blockchain code on Stack Overflow, but there was this trope, this stereotype of the programmer who goes on Stack Overflow, types in a question, and then just copy paste whatever he finds. And there was even a joke, I think, on XKCD. It was like Stack Overflow sort. It was an algorithm that just searches Stack Overflow for algorithms to sort until one of them works. It was like a joke. And I think it just. And this was before AI, right? So what we're seeing now, we've just streamlined this through the AI directly. People have access directly. There's no more intermediary. You don't have to actually go on the web to Stack Overflow to do this. People do this directly. They just vibe code. So I think I think vibe coding is something that in human nature, I think was something that AI revealed, but was always there. The nagging desire to not care, just ship whatever.
But at least I think that before, when you were, I don't know, searching for a problem on Stack Overflow, you should have at least understand what problem you have. Now it's like
yeah.
it does not work. Fix it.
Ideally,
you know?
yeah. I do the same sometimes. I think it's also there's this two things about this. First off, it depends a lot on the project you're working on. Of course, if you're working on blockchain, you should be scared, and people are not scared. Yeah, you see, people have a baffling lack of fear, which is yeah.
Maybe there should be a manifesto like blockchain code should be written only by hand. Or,
No, I don't.
no.
I don't agree with that. I don't. I thought I was naive enough. So when I started this, when I met the guys and when I started with Elrond, I thought, it's blockchain, it's a lot of money. So why do we want mathematics? Why do we want really, really proper ways of doing things, really proper ways of programming? Well, because there's a lot of other people's money, or your own money on the blockchain, and to go back, like formal verification and like it's really advanced stuff that is really difficult and nobody wants to do because everybody wants to just copy up from somewhere, just code. Nobody was doing it back then either. You had it implemented a little bit in the aerospace industry, where people's lives are really on the line, with NASA, like space stuff up in the air, and it was making sense for blockchain because there's a lot of money. There's a lot of financial stuff, a lot of money. And in my naivete, I thought, well, people are going to realize there's a lot of money on the line and going to get really, really serious about the programming. And it was not the case. But then I thought, okay, fine. They don't have the foresight to do that. But surely once money starts truly being lost, like, people will back off and will say, what are we doing wrong? They will have this like eureka moment, like we've been doing this wrong all along. But no, this also did not happen. Proof being the long list in rect.news. It's a lovely website. I recommend it to everyone. It's a website that catalogs all hacks. And there's also, there's a lovely leaderboard. A black negative leaderboard with the biggest hacks. I think the biggest one is like hundreds of billions, or
I don't know exactly. I know the most recent hacks.
It's a stupid amount of money that was lost and hacked and misplaced. And not even all of that was actually was hacked by hackers. One of the first ones, like the DAO hack, was simple.
That was 60 million.
Sloppiness, like at the time at least. It was simple sloppiness. People were not careful. The tooling was not good. There was no there were no safety rate. There was nothing,
What was there? I think there was a misplace in the order.
Yeah, they placed it. They placed it wrongly in some contract that nobody could get it out anymore, and it was a huge sum. It was like, I don't know, a significant percentage of the whole. Well, TVL at the time was mostly the Ether.
Yeah.
There was very little DeFi. It was a significant chunk of the Ether, and then they just split it and they made Ethereum. Ethereum Classic was the conservative. Part of the community who said, we're not going back, this is against the blockchain ethos, and the other ones were like, now there's a lot of money, we're gonna
let's start it from scratch.
Let's leave a bit principles aside, let's get our money back, and let's do this. And this is a recurring theme in blockchain to this day. You have a big hack, people have lost money, what do? Do you stay strong and uphold your principles and immutability, or you just make a fork or something, or just vote to confiscate or freeze the funds or something like that? Which is a slippery slope. It's an entire discussion. I think there's no easy answer to which one is better, but there's an easy answer from what the programming involves. We should not get into these situations anymore. I don't know what the solution is, because apparently more money at the problem was not the solution. More money lost was also not the solution. I don't know what the solution is. I also sort of blame the fact that money was very cheap on blockchain. We had the last bull market again was with a lot of investment, a lot of money placed in all kinds of things. Sometimes markets do that. When there's a lot of money in the market, everybody wants to invest. It's very hard to to have the discernment to really understand what the projects are doing. It's really hard to evaluate the security risks because I feel we as an industry have not been doing a very good job, not only in having better security, but even just evaluating security. Like, is this piece of software reliable or not? How hackable is it? It's very hard to answer that question. And unfortunately, not even audits always, they're important, they're necessary, but they don't catch everything. Either there's been a lot of huge, horrible hacks on very well audited protocols, unfortunately. So my opinion is we should start as a community of programmers, as an industry, we should upgrade our practices. And I don't think it's enough to just write code the same way, just a bit better. So for instance, there's a book called Clean Code. Great book. I think every programmer should read it. There's actually a series. All of them are great. It helps a lot, write better code, but it's still not enough. You're gonna write the cleanest code, it's still not gonna be enough. And I think the only thing that's gonna be enough is ultimately resorting to mathematics and stuff like that. There's a nice saying that people in formal verification in industry say, you wouldn't want to travel on a bridge or sit under it or live in a house that was not calculated, right? Where the architect had no idea how to calculate like stress and resistance and stuff like that, right?
Yeah.
We wouldn't do that. Sure, 2,000 years, pyramids are amazing. They didn't although they might have calculated quite some stuff there. In the Roman times, they were building these huge structures and they did not have the mathematics, but they had a lot of good rules of thumbs. Same in the Middle Ages, the cathedrals were not built with mathematics and modern tooling. And you'd say, well, yeah, but look what they've done without mathematics. Well, no, actually, a lot of churches collapsed as well.
Yeah.
So we actually have the ones that haven't collapsed. So it's a dangerous thing, to build houses and structures without
Trial and
mathematics. Yeah, and at the same time, people don't see the fact that in programming we're doing the same. Basically, we're okay. Regardless if we're vibe coding or not, we're still doing things a bit by ear. In the end, AI only imitates us. The way AI works, I feel, is very similar to how people work because AI learned from humans.
Exactly.
So we've been doing programming by ear, like since forever. And AI is doing the same. I don't think AI is capable on its own to change the way we do programming. It's gonna do it a lot better, a lot faster. Do a lot more mistakes because it's doing more of it, but it's not going to change fundamentally how you do programming. And that's what I feel is the problem that nobody's seeing. I mean, there's a few weird guys in mathematics field who are a lot more smarter than me. There's me who I want to be like those guys. And what's also shocking about this, research into programming languages and sort of into the more mathematical side of programming has been around for a long time. If we want to be to be fair, from the very beginning. So from the very beginning, we had Turing, who did the Turing machine, and we had Church, who did lambda calculus. So from the very beginning, there's mathematical models flying around. And then there's some really amazing research from like the 80s, which is already like 40 years ago. And all these programming languages that are being researched, and all these concepts that are coming. And in the 90s, you have like Haskell and stuff, and all this functional programming stuff, and you have more and more like formal verification languages and all kinds of techniques to make sure that the code works like mathematically. And none of them become mainstream, right? None of these are really mainstream. The most that we got out of it was like features here and there, features that were like seeping slowly getting into the mainstream languages. Like at some point Java got lambda expressions, at some point C got like these cool generics, but you're never getting the full package. You're usually getting like bits and pieces. Then Rust has gotten a bit out of that with like sort of linear types, affine types to be sort of linear types, and then you get like really basic algebraic data types, which are again a very cool thing that I personally think every programmer should know about. It's really cool subject. but it's still not quite mainstream, not quite, not quite. If you're in a good in university and have some good teachers, if you're lucky, you might get a course on that. If you're unlucky, you'll say it's complete bullshit and you're never going to use it in your life. And it's not quite correct. I mean, in a certain way, maybe we're not going to be using these advanced programming techniques and the mathematics of it. You're not going to be using it explicitly. There's a good chance you're not going to find a company that has one of these like really crazy experimental new languages, but still the concepts in your brain, should be there. And when a good programmer looks at a piece of code, he can see all the ins and outs, see everything that. So in the mind of a programmer, there is this model. You could argue that model exists. Just maybe you didn't put it on a piece of paper, you didn't express it, and you have it in your head. It's hard to prove to somebody else that what you're seeing, which I think it's a bit of a loss, because there's actually another very cool question, like how do you make a senior software programmer to this day, right? Because universities produce junior software developers, right? So for the most part, a software developer that goes out of university is a junior. And usually, how the way we quantify how much experience how good a person is by the number of years, which of course is an approximation, but it's what we have. I feel that's a problem a bit. I mean, that indicates the fact that we have no better way of quantifying how good a programmer is. And this also implies that we have no way of quantifying how good code is, because if you could quantify how good code is, then you could probably also evaluate who wrote that. But we don't. So we're like, and intuitively we know that the software programmer is able to steer the ship well, is able to write code that has vision, that has perspective. But how do we quantify that? It's very difficult to tell. And especially that's something I see every day in our work on a blockchain, because you can definitely you can see the taste, but it's very hard to quantify it, And you can see a project that was well thought out and that in 5 years it's blooming really nicely. It's working really nice. People are really happy using it. And there's then other projects that, they have all the features, but they just feel a bit off, and they're hard to develop, and people are having all these problems. And then the team is having a very hard time to keep up with the problems that are piling up, and we notice this, we know this, we have an intuition for this. Everybody who's been doing this for a long time can really see it. There are smells, there's taste. Copilot can go like, this doesn't feel right. But it's very hard to say, this is on solid, this software was built on solid foundation, this one was not built on solid foundations, because we're not usually discussing these foundations. And I was hoping that blockchain would actually be a catalyst to that. Like, okay, there's money on the line, we better do things right, we better build on the good foundations. Okay, let's see what these foundations are. Didn't happen. Or at least not in general. We're trying this at MultiversX. I think we've been doing an above average job, because and that was actually the value proposition that we always offered. This sharding, the whole protocol, the way it's designed, it's supposed to be a really good foundation. Problem sometimes with the good foundation is it's hard to evaluate in the moment. You often see the impact of a decision in 10 years. 10 years is a long time for investors, or for products. So yeah, but I think otherwise, you're gonna keep reinventing the wheel, keep going in circles, keep losing money, and it's a pity. Yeah.
I want to take us back a few years, I think 2 years, and I'm happy that you mentioned the entire formal verification and mathematics around the programming languages and so on. Because if you remember, I think we first started having those conversations with runtime verification 2 years ago, or even more.
I mean, we started in 2019. Strictly speaking, we had their whole VM, and they made a copy or an adaptation of their whole VM. So we've always been in contact with them. They've always been amazing. They're a great team to work with. They're really, really amazing. They also have this option now called Pi2 that's using similar technology to achieve different kind of things. So it's a great piece of technology. It's called K-Framework. It's like a language for defining other languages. Formally, it's really, really nice. We have an integration with them. Like around 2 years ago, we built it. It's called Casmer, I think.
Casmer,
K with K and Wasmer, yeah. I was trying to remember why it's called Casimir. Yeah, it's Kane Wasmer. Right, and yeah, basically they've built a whole model of RVM, which includes WebAssembly, and then what we've the stuff we've built around it, like how you do calls, how you consume gas, how you format transactions, and so on. And it is possible to use it to do something called symbolic execution. This is a kind of strategy to ensure that code is correct. For the moderately technical people out there, it feels a bit like fuzz testing. Fuzz testing means you take a piece of software and you throw a lot of values at it. It's like an automated automating monkey testing. Okay, like you're automating a horde of monkeys to go and try to cram into that all kinds of inputs and see what happens. Thing is, with fuzz testing, it's very good, but it's finite. I mean, you might still not catch all the bugs. Of course, it's you're increasing the chances to catch bugs by throwing a lot of inputs at it, but it's never 100%. Whereas symbolic execution turns so you take similar tests like the fuzzing, but then instead of doing it with actual real values, you replace it with like symbolic values. Like you turn the whole system into an equation, like you just x. You don't try for like 100 values of x. You just put x and leave it like that, symbolic, and then try to solve the equation and see if you can prove that for any value of x, certain invariants hold. For instance, the sum of all balances is the same. Whatever happens, there's no money created or destroyed. That's a typical invariant that you would want for a system, which is cool, important, and most importantly, it's more accessible to developers because most developers will be capable of writing or at least thinking about some fuzz tests, like and then turning a fuzz test into a symbolic execution sort of process could be something an easy step for a programmer, whereas doing proper formal verification is not easy. It's not easy. Actually, writing the proofs yourself by hand is tricky. People with PhDs do that. Not to scare anybody. Things have gotten a lot better now. There's a lot of research into having AI help with writing proofs.
Exactly, yeah.
I highly recommend. There's a great mathematician, Terence Tao. He has some stuff on YouTube out there, including I think a Lex Friedman podcast. He has some YouTube clips of himself. He is investing a lot in this, like figuring out how AI could help us write proofs. And it's also very useful for mathematicians because a lot of problems in mathematics have been unsolved for years. And this sort of computer validated way of writing mathematics is really cool. But it also is very useful for us programmers. It's not so popular yet with programmers, again, because it's still a bit difficult, but it can be done. And the symbolic execution is a lot easier, right? Problem with it is, so we managed to build a prototype out of it. We managed to symbolic execute 2 or 3 contracts, which was cool.
Yeah, I think
and then we just shelved it for a while. Why? At the time, I was made aware they had the similar product on Ethereum. There were like 12 people using it on Ethereum. It was like scaling for size. It will probably not be so many with us. I'm trying to revive it now with the help of AI. A lot of limitations with our team has been bandwidth. We're not that many people, and we've never been that many people. So you can't just throw limitless resources. There was literally nobody to pick it up and turn it into a friendly, easy to use product. So the pieces are there. The proof of concept is there. It kind of works, but for now it's a bit difficult to use. Because not designed like our framework to be easy to use for everyone yet. There simply needs to be a lot of effort put into this. Now with AI, we might pull it off. I recently had a request for someone in the community who wants to formally verify their contracts. So I might pick it up again. I did look into it again. The code is there, it's waiting patiently. And I want to turn it into a product that's like integrated into our whole tool set, and you can just like go in and say, yeah, let's formally verify this. Let's do this.
I remember the community reaction at the time. I think it was quite before AI just
Yeah.
took off, and there were lots of questions. We were presenting
Yeah.
also in the developer sessions and so on that we are working on this framework of formally verifying and symbolic executioning and so on. And there were lots of questions. What is it? What do we need it for? How will this bring adoption and so on?
Yeah.
And now, fast forwarding 2 or 3 years, like for today, when AI is just everywhere,
Yeah.
people who are not technical could find some of the bugs, even though
Yeah.
they do not understand them,
Yeah.
but just prompt them in a way how probably a technical
Yeah.
people will not think, just because I'm sure they did not make this mistake, but it happens. We are human, right?
Yeah.
And I know that we had one of the issues, if I remember well, was the fact that to write one test, so not generate, you had to write the test for the other contract or
Yeah.
whatever we had.
Small contract.
It was
yeah.
like 1 week, and we were like, okay, it takes a little too long, probably.
To execute the test, yeah, the symbolic execution is kind of slow. They were working on it. They actually improved its speed, but yes. So actually, to run the process itself, it's a pretty computationally intensive task. For a small contract, it can take like an afternoon. For a big contract, maybe 2 days or so. So it's not fast. It's not something you just type in and go and you're getting it, or you're getting it in a minute. No, you have to wait like a day or two, because what it's doing, it's literally exhaustively exploring all possible options, everything that could possibly execute in any possible way, which takes a lot of time. And yeah, there's ways to improve it. As an aside, we always had it in the back of our head. The way we designed our framework, the way we designed our VM, we always wanted to make it in such a way that it is easier to formally verify it. I don't think you could even run it on some other chains. So one of the reasons why we were so obsessed with having very small smart contracts, our contracts are like 1 kilobyte, 10 kilobytes, something like that. They're very, very small. They're not 1 megabyte. Was because when you formally verify, you want to load the whole smart contract, in this sort of symbolic memory. And it's also kind of expensive. And then you have to run and see everything that could possibly run. And to give it the best shot at doing this faster in a reasonable time, we want to make everything very compact, make everything very precise, very small, very minimalist. It still takes a lot of time. But it's also what you're getting out of it.
Exactly.
That's the thing. Like, okay, yeah, it runs 3 days, but it's not a regular test. This is something that will ensure, beyond a shadow of a doubt, that what you've done is correct. With an asterisk there.
It's not absolute.
It's only as good as your specification is.
Exactly.
And it's only as, the guys from runtime, like Grigore Roșu, head of runtime verification, was often saying, formal verification doesn't ensure that everything you wrote is correct, but it shows you the exact assumptions that you've made. So code is only always as good as assumptions. There's always assumptions. But formal verification will specify those assumptions very, very well. There's always an if at the beginning. So, okay, in normal conditions, if this and this and this hold appears or disappear, or people can't have their money taken away from them, or stuff like that. Then you get 100% sort of 100% confidence in your code. It also doesn't fix the human factor, like phishing and stuff. Doesn't fix the web problems and so on. But at least the code, for sure it's good.
For phishing, there's the human factor.
Yeah, exactly. So it does that. Yeah. But that's why this is very powerful stuff. It also has to exist in a broader context. It's not the be all end all security. Also, the way I like to talk about security is like a pyramid or like a mountain, right? You start from the bottom, which is broad, but doesn't give you so much confidence. You start like with a good linter, right? With some unit tests, like basic stuff. And then you build up. You build integration tests and so on. You build fast testing, And after that, you try symbolic testing. And if you really want to write a formal proof of something, then you're at the summit. But you can't just go directly there either, because you might have a lot of bugs that are a lot easier to catch down there, a lot less effort. So you have to go through that also.
Nothing stands on a bad foundation.
Nothing stands on a bad foundation either, yeah. But if you have a big DeFi product, so maybe if you're just deploying a small game or something, maybe you will not go to the trouble to build it. But if you have like a big DeFi protocol with a lot of money in it, and your business and your reputation and your money rests on the fact that that code works correctly, then you're gonna want to spend a few days, even if you have to wait for a week for it to churn out the fact, or to churn out a counterexample or find some hidden flaws. You're gonna wait for that, in a way, we do the same with AI, right? AI is also pretty expensive, and it has to run. We usually run it on big clusters and big data centers, and we accept the cost because we like what it produces. It's the same here. Like, you have to pay a bit.
It's kind of funny that AI is part of why we need it again, and probably, and you mentioned it, AI might also be the part how we will make it more tractable. Like,
yeah, it might help us build it easier. But so that's another big idea that I like very much. I feel that AI and formal verification are a bit like a yin and yang. So they can complement one another very, very well. It's very difficult for them to do each other's job. AI is great for exploring, for building stuff fast. It's like having 100 people on good programmers on steroids doing stuff. It cannot give you confidence but then again, traditional programming was also not giving you the same confidence. Formal verification is a bit slow. It's a bit more difficult to use, but it can give you confidence in what the AI has produced, and then AI in reverse can help you build it faster. Maybe
specs, whatever.
proofs, stuff like that. We're still working on it. I mean, not me. Humanity is working on getting AI to write proofs and stuff like that. But we have to sort of be curious about it and at least care about security. Again, going back to MultiversX and the ecosystem and why we shoved at the time, in the community, there were a lot of builders at the time, and like the majority of them, because we were looking at their code, did not even have unit tests.
Yeah,
like, guys, what you're doing? So, and was like, people are not testing their code at all. They were testing it. They were testing it like on chain. They were deploying it and sending some transactions and figuring out what happens. Like, man, that's slow. That's tough, and it's not reproducible. It's expensive, but it doesn't give you a regression.
Yeah,
like,
exactly.
You test it, you change something. How do you know that you have to do the test again, right?
Yeah.
So actually, what I did like 2 or 3 years ago, after this major revelation, was that we needed to be very, very serious and invest a lot in testing infrastructure, make it very easy for people to test. So I spent like 2 years trying to make testing
I remember.
a better experience, which we did. I don't know if it helped so much, but
did you start SC Meta around that time or a little before?
No, we had SC Meta in the Elrond days. Just got rebranded. There was an Elrond Meta or something.
Okay.
We split it at some point into two things. That's a bit of a technical. I'll try not to get too deep into it, but it's two things actually. SC Meta is two things. It's like a CLI, a tool that you run in console. It's like a Swiss Army knife. You do everything with it. It's like you go there, it helps you everything. Set up contracts, run them, stuff like that, build. And then there's another small component that we usually attach to a contract, which helps with building the contract. It's usually automatically done. You don't usually care about it. It's there. And that will help you build the contract. And that's actually the original one. It's called meta because it's meta programming, because meta programming means having writing code. Way before AI was cool. You can have, you can generate code programmatically, and that's called meta programming. And I think it's a very powerful tool, very underutilized, dangerous as well, because if you rely too much on it, you might write crap code. That's why usually in school, you'll be like, don't do it. But my take is you should do it if you know what you're doing. Yeah. Anyway, and that's how the whole thing worked. I was briefly considering to rebrand it into something like MultiversX, your everything tool, but nothing quite rolled off the tongue, and people were getting used to SE Meta, so it stuck. Yeah. So it's a meta programming thing. It just does stuff for you without AI. So.
Yeah.
Which is another interesting subject if you want to go into this. I've also had a bit of experience with this lately.
With what?
So, generating code. So AI generates code, right, in its own way, more like a human would. But then, of course, you also can have programmatic procedural code that generates code. And pros and cons. That was an interesting thing that I did. Actually, it was one of the first things I did with AI. There was this old format for tests, and I didn't like it. And I was like, come on, I want to migrate all these tests to the new format. And I did. And I was like, AI, come on, migrate this from old format to new format. And I was looking through the sources, and I had omitted some tests. I'm like, come on, where are those tests? And thing is, it was actually very hard to keep track of what the AI had migrated and what it hadn't migrated. And you can't rely on the thing, right? It did its best effort. And it was not even such a big problem, the fact that they did migrate everything. But I find it more worrying that I mean, I caught it almost by accident because it was a bit blatant. But I could have just skipped a test or two, and in a few thousand lines of code, you miss that, right? Because you're a human, you don't. So then I thought, look, this old testing format, we have parsers for it. We know how to deal with it. Why not just do the migration procedurally? Of course, not by hand. I had the AI build procedural code to migrate the tests, but this time the AI was not doing brute force. It was writing a tool, which I thought was nicer to the I sometimes imagine, so AIs work a lot like humans, right? They are taught to work like humans. And one of the main rules that we have in programming is you should be lazy, right? You shouldn't do grunt work by hand. You should automate stuff as much as possible. Yeah. And I think it's the same is valid for AI. So if a job is too boring for a human, it's probably too boring for an AI. If you could automate something that a human wouldn't want to do, then probably you're going to be better off automating the same thing for AI, right? Because suddenly you're restricting a lot the space of possibilities. Whereas AI can write all kinds of code and take all kinds of input and read all kinds of specs, a procedural tool that converts, for instance, from one format to the other does one thing and does only that. And you're guaranteed that you're getting everything, and you're guaranteed that if something is wrong in the input, you're gonna get an error, stuff like that. Whereas AI might brush it off. So again, I think we're just starting to explore now this again, a bit of a yin yang thing, right? The AI being more like a human in that it's a bit more like creative and can process things a bit more high level. And then the low-level machine thing that can also validate, but also help AI produce stuff. And I feel that a lot of the work that's been done in the agentic programming field has been marrying this kind of, these neural networks with tools. And I like it very much when I see like Claude run. That Claude, for instance, if it has to find something in a file, it won't just load the whole file. In his own memory. That would be like a human reading through every little bit of it. No, just write a script or run a set or find a command. Yeah, sometimes like a little Python script or stuff like that to do. And I think this is the way, because to make the most out of AI, we shouldn't give it like tedious machine jobs. It's a machine, but it's not that kind of machine, So I'm trying to do the same with our tools, like to offer the people. So the stuff that is simple, that is straightforward, that is deterministic, we should keep it that way. For instance, a build system. A build system should be very clear what it does, what it produces. It should give you some guarantees that it always runs like that. And of course, we're using AI. So AI in this case is the meta programming, right? It's you have the program, you write some meta program to do stuff about it, and then the meta program, of course, you use AI. So I think this is I'm very passionate about this. I think it's actually been doing a lot for a lot of programmers, and I'm not the only one who noticed it. Obviously, Anthropic is doing the same, and probably other agents as well.
Yeah, so it's funny. We are experiencing a lot on the system that we are building, the AI system, and we've seen exactly this behavior. Claude, in general, is building lots and lots of scripts,
Yeah.
be them Python or shell scripts, whereas other models are not doing that. They're just brute forcing and
Yeah.
calling and trying to find
Yeah.
everything by tool calls and so on. And it's not efficient.
Yeah, it's not efficient. It's a lot harder for them, and it's a lot easier for them to hallucinate, to go off
Yeah.
the rails, because I mean, we have to be a bit empathetic with them, but they can only do so much. They only have so much memory, and also after using the same model for a while, at some point,
Yeah.
it can't focus anymore. You can't keep it focused forever. So everything that you can offload to something like more simple, a machine, you should, yeah. It's like, in a way, it's like a human. It gets bored. I'm not doing this anymore. It's like, it gets tired. It doesn't see stuff, I mean, of course, not a human, but it feels that way,
But
It feels,
about seeing stuff, and now speaking about aggressive code, brute forcing, testing, and trying all doors and windows, we had Battle of Nodes,
yeah.
and just happened. I think it finished last week or 2 weeks ago,
Not
and
anymore. Gee, time flies.
yeah,
It felt like a long time ago.
and I think there were some findings reported also against VM, or some findings around the framework itself.
No, we didn't. I don't think we have anything in the framework. Might have been something in the VM, but it was not critical, so we just postponed it. There was a finding, there was a problem in the VM, but I don't know. I think it was before the Battle of Nodes, and we just circumvented it, and so we left the Supernova guys alone. So to this moment, the VM has no changes for Supernova, and we managed to keep it that way. Nothing critical was found. Yeah.
But also there are lots and lots of findings which are being reported, like
Yeah, I
hundreds of them.
I know.
And
There's also money on the line, you always get a lot of findings when there's money on the line, which is good. We've also had some mainnet, so non-supernova mainnet upgrades because of findings that have been found as part of the Battle of Nodes, which is good, because if we didn't find them, somebody else might have. I'm not part of that team. I know some of them were worse and some were lighter, but still all of them had to be fixed and in a timely manner and so
Yeah.
on. Which is also why Supernova maybe might feel a bit late, but in the grand scheme of things, it's better that everybody's money is safe. That's always the best thing to have. Yeah.
but I'm curious, because you said you are meta, I don't know how many levels.
You can go as many. There's infinite turtles. There's turtles all the way. That's the saying.
How do you communicate with the agent? It's like talking to a person, or it's more like talking to a machine?
It's a bit like talking to a junior. Yeah, having to work with a junior experience. It's pretty much like that.
Which is still an engineer.
Which is an engineer. Yeah, it's really good. It's really good. It's really hardworking. It's really fast. Sometimes you underspecify, so I just assume stuff, and then you're like, oh man, yeah, you're right. I did it. It's on me. It's on me. That's why I never felt like I need a more powerful model. I felt I need to be better at giving it prompts, and I would say for the past few months, generally when it didn't understand, it was usually because I was not very specific. So that's one thing. But occasionally it will assume that it understood and will do something that is absolutely not what you asked. Even today it happened to me. I changed my mind. It's also an interesting thing because you have it. It's always there. Unlike a human, which might take like 2 days to do the thing. So it's very easy for me to go like, okay, let's do this. And I look at the code and like, I didn't really think this through. We might have to revert part of it and so on. And I can do this back and forth with it. Um, but yeah, sometimes it's like a junior in that it's very eager to solve the problem without necessarily having it understood very well. Which also is the reason why I have to keep a close eye on what it does. But it also surprises me a lot. It's like it sometimes feels like this junior development who just came off school and maybe doesn't have the taste or the experience or the broad scope or can't plan ahead very well, but it knows a lot of cool technology stuff that you don't know, because it's newer and stuff like that. It often surprises me with finding solutions to problems like, oh man, I didn't know this thing existed in Rust, or I didn't know this tool exists or that works that way. It just fixes a problem like that. But it's usually shallower things. So I have this tool, okay, I don't know very well how to use it. And then it finds a way. It finds a way. So if it's something that's a bit shallow and just out there and I don't know it, it's amazing. It's really amazing. I'm really impressed with it. Actually, one of the first things that I did with Claude was clean up our continuous integration pipeline, which is in GitHub Actions, which is a nice technology, works very well. It's horrible to write. I hate it. Everybody, it's also horrible to test. It's very difficult to test. I tried. I barely managed. It would have taken me a month to go through. It would have been like a tedious chore, a horrible chore. And it did in a few days. Like it was like, yeah, let's do this. Let's do this. Why doesn't this work? Oh yeah, you forgot to put this there, and so on. I was like, oh, that's really good. It's really good. And actually, for me, it's a huge revolution because we've always had a huge backlog. Was never able to take care of all of it, and now with AI, I have a better chance of sorting through all the stuff.
But the backlog is still long.
Oh, it's a lot shorter now.
Ah, really?
Yeah. We've done a lot of progress. And actually, what I've been doing like the past 2 or 3 weeks, again, something that we've been wanting to do for ages, and would have taken a long time because it involves Python, it involves all kinds of things, and I don't know Python or very little. I wouldn't have time to go to all the sources, would have been difficult. Would have been a lot of lines of code to write. Same for that tool. That tool ended up being a few thousand lines of code. That would have taken a long time. Whereas AI wrote it pretty quickly. I had to review it, but it was a lot faster. So
help me paint this picture. Editor.
I use VS Code. I'm a basic. I know there's a lot of people who have very strong opinions of VS Code. You should use Vim and stuff like that. I'm like, no, I'm a simple person. I'm a simple man. I click, it's fine. It works for me. Yeah.
Model.
Claude Sonnet 4.7. Yeah.
So you said Opus is too...
I tried it. It was too much. I didn't need it. It was doing too much, and it was it was
too noisy.
Too noisy. Yeah, too noisy. It was doing too much. In programming, one of the thing that makes the big Jedi programmer is knowing where to stop. Knowing where to stop with abstraction, knowing when to cut stuff out, where to simplify. Usually, beginners do things very simply because that's all they can do, and then intermediate programmers, they do everything very complicated, and then senior programmers, they do everything very simple again. So I like to keep things contained and simple, yeah, with the model as well. But it's very powerful. So it's very powerful.
Agent.
It's Copilot, right? Is the one that's integrated, yeah.
So you're using Copilot as an agent, okay?
Yeah, and also for reviews, it's also Copilot. I think it's also Claude in the backend. I'm not sure.
So that would have been my last feedback loop. It's actually Copilot, but there's one intermediate one. What hardware are you using?
Oh, I run a Mac. I'm very happy with a Mac. I bought it like 2 years ago because my computer was literally falling apart. And I was like, maybe it's time for a Mac. I had this dual boot Ubuntu and Windows because I sometimes need Windows. I still have it. It's a very old computer. It's falling apart literally. And then I said, maybe I need a Mac. And I got it, and I'm so happy with it. It's amazing. And I was surprised, and it's funny because I'm not an Apple guy. I don't have an iPhone. I don't have anything other than the Mac that's from Apple. And it's funny because my wife, she's huge into Apple things. She has every Apple gadget. And she also has a Mac, but she hates it. So maybe the Mac is the odd one out. It's it's not for the Apple people. It's for the
Funny. Um, do you run open source models on your hardware?
I haven't tried it. I haven't tried it yet.
Do you plan on trying it?
I mean, I'd love to, but you know how it is with a backlog.
Yeah.
Yeah, I think that's actually a very, very interesting thing. To have an
Because
open source model and to run it, the way you want
the
it.
next question is, if let's say you don't have internet for tomorrow, or
Yeah.
anyway for 1 week, how difficult or how much would your entire setup change, and how much would it slow you down now after using it for
Yeah.
1 year?
I would probably focus on the tasks that don't require as writing as much code and more thinking. Um, yeah, I don't think it would slow me down that much. Yeah, the thing is, it's a very good question how much X's you get as a
Yeah,
programmer,
exactly.
Yeah,
That's
how
what I
many
wanted
X's?
to reach.
We've had this discussion was very important in our company because we're a bit fewer now, and if you ask Benny or Luch, you should be 100x or 50x or at least
In
10x,
productivity,
at least
yeah.
10x in productivity. Thing is, I was really productive before as well. So credit was credit due. I was really productive before as well. So for me, it was a great improvement in writing the code. It goes a lot faster.
And testing it probably, or reviewing. You said that.
Reviewing is nice. We used to have reviewers who would spend a lot of time reviewing, yes. And they were a lot nicer to me, which, is not great. I like being judged very harsh. I like the code to be judged very harshly. So yeah, reviewing actually was a lot of time that was going into that. Although I still have to review it myself as well. I have to know what is in the code. It doesn't, I only truly vibe code if I don't care so much. If it's a tool and if there's some other layer of security, like a code generator, right? Which in the end will have to compile and work. Then yeah, fine, whatever. I don't care. Usually I have to know. So yeah, that's one thing. Depends a lot on the task. So for the core task that I'm doing, for refactoring and stuff, moving code around, writing code, yeah, that's a bit of that slows you down because you will be surprised. It's sometimes hard if you have many smaller tasks. It's sometimes harder to find the code, to find where you have to change stuff, than to write the code. I also have this idea that English is probably not the best language to program in.
I'm
The
happy.
reason we like programming in English with the AI agents is because all programming languages suck. I said it.
Yeah. So
Programming languages are nowhere near what they should be.
yeah.
In principle, a language written specifically to solve a problem, in a computer system should obviously be way more specific and way more compact and way more expressive than English. The fact that we consider English to be a lot easier to work in than these languages is not sitting very well with these languages. But these are the languages that we have, right?
So I have to ask you this one because we've talked before offline, so
Yeah.
not online. And I know you wanted to build a programming language. Is
Yeah,
that
I don't
a
know.
niche?
I think a lot of programmers, most programmers, I don't know how many, a lot of programmers, their secret dream is to build a programming language. Is the stuff that everybody wants to do. It's the stuff that absolutely almost nobody should do.
Okay.
It's like eating junk food. You probably shouldn't, but it could be cool. Yes, I'm very passionate about languages. Also because I think we're nowhere near where we should be with languages. At least with mainstream languages, it's not great. With research languages and new stuff coming out, I think there's a lot of very cool stuff out there. I don't think there's this amazing ultimate language anywhere yet, but I think there's very good research done towards that. I also often say more or less jokingly that Rust is the worst language except all the others. Paraphrasing, I think Churchill said that democracy is the worst except all the others. Something like that.
Yeah, exactly.
It's the least worst mainstream language by far, but it has huge problems itself. So we probably would be nice to have specific languages for jobs. Oh, also, I forgot to say something related to how much faster it is. There are sometimes, not very often, but maybe in 5% or 10% of the cases, I am faster than Claude.
Okay.
Okay, so there are cases when I'm like,
You're more
okay, we have
efficient.
to, yeah, I mean, I can literally go in and change the line of code that should be changed
Oh, okay,
faster than
that's true.
Claude processes it and understands everything. You know, that 1 or 2 minutes when it thinks, I'm like, I
Yeah.
go in, I fix it. So sometimes I can be faster than Claude. And those are the moments where I feel the architecture is good, the programming language is helping me. I'm more expressive in the programming language that I am in English.
But here, sorry to interrupt you. This is the version of the question I'm actually interested about, and probably it will help you in building your.
Oh, by the way, I think I'd say 3x. So
3x?
I bought 3x, yeah. 3x, I would be slower. Or I am faster than I was like half a
Okay,
year ago.
That's an interesting answer. But
That's what at least what that I feel. And it's not more because for several reasons. It could be more, but the reviews, I go back a lot more to fix a lot more stuff because the reviews are better. I have to think. I still have to think. So
thanks God.
yeah, I
We
still have to
to
think a lot,
yeah.
and I have to come up with solutions that I'm still just as afraid to start on a big refactor because the mental stuff, the high level mental stuff, it's not gonna be done. It's gonna be done by me. It's helping me a lot, but it's not thinking instead of me. I think that's what I'm trying to
Yeah.
convey. It can code for you, it cannot think for you.
Mm.
Although when I'm a bit overwhelmed, for instance, I'm migrating something from a code base that I'm not familiar with, I very much like to tell it to just make me a summary of it. What does it do? And I ask a question. What happens if I do this? What happens if I do this? And then it would have taken me before. It would have taken me like 2 days to go through a code base I'm unfamiliar with, maybe in a programming language I don't know, and be like.
But
okay.
you still do it. I mean, after.
I did migrate a code base from Python to Rust, and I still have no idea about the Python code. So
really?
yeah. So I told it to migrate. First, I told it to explain to me, to map out all the APIs. I'm not like learning Python now. I mean, I also don't like it very much, but I also don't have time. I wouldn't mind if I had a lot of time, but I don't. So I asked it to write documentation for me. There was some documentation, but I asked to write it in much greater detail, which by the way is another thing that's really nice. I'm now asking it to write documentation for everything that I do. So everything that I touch, I'm like, does this have documentation? Does it have readmes?
But
No,
please,
go, write.
Please push it also to the docs.
Most of the documentation I do is in code. So like Rust docs and readmes and stuff like that. I'm probably going to go into, that's another can of worms. Even with AI, it's taking a lot. But yeah, also documentation is a lot easier to write now. So
Yeah, that's right.
and it's telling me, okay, this is what it does, this is how it works. It's translated it very well in Rust, which I'm much more familiar with. I can understand what it does. And then and now I have a Rust code base and I can pick it up from there. So that was nice. That would have taken like weeks. I don't know. So I would say 3x because I still have to think a lot. And and writing of, if you have to write too much code also, that's a code smell. That probably your code base is not great. If the health of a code base is can be measured informally by how much effort it is to add a feature or change anything. If you have a really messy code base and then every change you make will break other things and with cascade, it's going to be a nightmare. If you have a very well organized code base, which we do, then it's not so difficult. You can just go in like surgically and fix this and fix that and add this and add that. So from that point of view, that's maybe like 1.5x. But then some other things are 10x because there's stuff I don't want to deal with, or it's stuff, that's not so important. So
on average,
I say 3x, 5x, I don't know. And if I didn't have internet for a week, I would probably think, although I'm also doing that with ChatGPT and Gemini, I'm doing a lot of back and forth brainstorming and stuff. It's also very nice.
Hmm.
And asking them, have other people tried this or tried that? That's really nice. It helps a lot. It's like having a person to talk to, you know. Although, and I was going to say and not go crazy alone, but apparently there's people going crazy with ChatGPT and with
Yeah.
agents as well, because they're so sycophantic sometimes, and people sometimes go on a loop together where they're hallucinating with the AI. This can happen apparently.
Oh,
So stay safe, guys. Talk to a person in between the sessions as well.
or in between. But I've seen that models lately keep you safe from that.
Yeah,
Usually
yeah,
they
yeah.
say, "Hey, I'm an AI model. Stop doing
And
that."
especially these guys, these like Anthropic technologies, mostly aimed at developers, and also its tone is a bit more professional. So it's.
But-
Although I don't know, because you can't control it. And you were mentioning about running your own model, which is interesting. I think we should consider that.
I can
But,
help you
thank
setting
you.
it up.
Thank you. Although again, time is a valuable resource, and right now I'm really working well with it.
1 hour and it's done.
Okay, awesome, awesome. Hook me up.
About the programming language,
Yeah, programming language. Yeah.
who will it be for? And hear me out. Who will it be for? Will it be for humans to write or for AI to write?
Yeah, that's a good question. I think a good programming language is for both, because AIs do stuff that humans do. There was at some point, I think even Elon Musk, went on a thing at some point, was like, oh, man, why do we even bother with high-level languages? We just ask the AI to write the assembly directly. I think it's a terrible idea. I think it's not going to work because that's not what AI is good at. It's exactly the thing I was telling. Having high-level AI versus having a tool. Like the compiler is a tool, is a very deterministic thing. It does one thing, and I mean, it does many things, but it does this. It translates from high-level language to low-level language. I think AIs thrive in high-level languages. The higher level language, the better the AI, I think, does. And I'm going to open a big, there's a deep rabbit hole thing here. When people talk about programming languages, most people think about C and Java and so on. In the grand scheme of things, these mainstream language or Python, these imperative TypeScript, these imperative languages are very similar to one another. There are much more alien languages out there that the mainstream doesn't even think about very much. But I think one big thread that unites them is the type system. So it's a question like, if you had to design a language from scratch, what would you start with? And most people would say, you want to answer it or
No.
what would you think? It's like what would be interesting for a programming language to have, like first thing off your head, like people will say maybe syntax, or how nice the syntax is, how quick it is to, loops and stuff like that, force variables, It's a tricky question. Like, where would you start, right?
Now I'm thinking what you want to hear, because you're an engineer. Actually,
I'm a weird engineer, right?
That's why it's a tricky question.
It's a tricky question. My opinion, I will stop the torment. My opinion is type system. Type system is everything. You start from the type system, you build everything else. And people don't realize how crazy type systems can go. Actually, formal verification for programmers is actually in the type system. So whenever you write code in Coq or Lean or Agda and so on, it's actually the type system that is doing the proofs for you. So the proofs are actually resolved the same way that the compiler resolves your compiler errors. And the better the type system is, the more you can get out of it. So if you want out of the box formal verification, for instance, in your programming language, because that's a nice thing to have, then you need a really, really good type system. Or if you're on a blockchain, another example, let's say you want to use linear types. The linear types are these things that can only be in one place at once, like tokens on a blockchain. And famous language that has linear types is Move, which is a great language. And there's also, they're called types, right? So it's in the type system. Again, the type system is doing this as well. So if you go really deep with it, you'll find that the type system can do a lot for you. And from a type system, you can build the rest of your language if your type system is good. Right. So I would, if I were to write a new language, I would think very well about the type system, and how it does, and how you construct stuff, and constructing stuff that you can then verify. That's, I don't know how much time we have. I could go on for a long time.
That's what I was checking before.
Yeah, how deep are we into how deep in the rabbit hole are we?
I think if we plan for this podcast to last for 3 hours, and we said we will make it in 2 editions, we are half the
Okay,
time.
it's an hour and a half. Okay, that feels like the amount of time that has passed. That's cool.
So what you are
I
saying
would
is
write a smart, not a general programming language that can also be used for blockchain with a good typing system, and trying to make it simple and try to target WebAssembly and stuff like that, but also make it work on the web. There's a lot of concepts that are out there that I think would be interesting. There are a lot of interesting languages that I think are worth exploring. One of them is Unison. Another one is, I've tried to play a bit with F star, which is also cool.
I've never heard of F
that's
star.
F star, yeah.
Okay, that's an
F
interesting
star is, it's like a functional programming language. It can also build WebAssembly. So I've been trying. Oh, by the way, I've also tried playing around with anti-gravity, but it was constantly overloaded and didn't want to respond to me. And I was a bit frustrated with it. And I wanted for it to build a F-star project from scratch. I'm still waiting for it to build it.
For anti-gravity, we probably should wait for Robert. He's a big fan of
Okay.
Gemini and Google related
Yeah.
AI stack. So this would be one of the things that would make your ideal programming language trivial.
I think, see what happens is formal verification is hard because you have to do it in a language. It's probably not your production language, and you're probably going to be specialized on it. And because we're not writing code in a way that is easy to verify. That's the big problem we do. Imperative programming is cool, it's easy to understand, but it doesn't give you a lot of safety. So at the bare minimum, we should all lower at least a little bit of functional programming. Functional programming can feel more cumbersome at first until you get used to it, but actually functional programming can give you guarantees. It can give you, naturally can give you invariance. And with a good type system, you can turn your programs into theorems, and then you can prove them, stuff like that. But I wouldn't know what to recommend right now. And that's why I've been trying to play around with, Casmer is good. It's an intermediate thing. Because at the very least, your language is defined at our VM is defined in Casmer, and then you can prove stuff using it. The problem with it, a bit of a subtler problem, is if it goes well and it's great and you get an okay, your code is safe. But if you have a problem, it's very hard. You have to dig through some very, very deep tech to figure out what the problem is. In some cases, it can give you a counterexample, but in other cases, you're gonna have to go through, the nitty-gritty, the engine room. You're gonna go to the engine room and see what's going on there, which can be a daunting experience. Whereas if you had that whole mechanism in your language, then you might prove stuff as you go. That might be easier. But then again, it's not enough to have a language like Lean. Lean is by the way, Lean is becoming very, very popular. It's very popular amongst mathematicians. By the way, it's a programming language that's used by mathematicians to prove stuff. And we can also use it as programmers, which is really cool, but it's a very high level language. So if you want to build something like a smart contract, you will probably need something else, something more lightweight. So, yeah. So I don't know yet. There's a lot of research to be done. Thing is, a good language is compact and a good language is easy to verify. Oh yes, and with the AI, thing is, we have a problem with the AI that it sometimes hallucinates, it does things wrong, it doesn't realize what it's doing. So how do you fix that, right? You either have some tooling or another AI to verify better than Infinite Turtles, right? How you can trust that AI and so on. So the best way to do it is to use stuff that's already in the language. That's the best thing you could do. Of course, you can have a script, you have a linter, but if your type system is telling the AI, hey, what you did doesn't make sense, doesn't compile, if you have a very, very, very strict, very, very aggressive language, doesn't allow you to do the same thing in multiple ways. That allows you very little leeway. Like the classical counterexample is C. You can do anything in C. Like C will be fine. You want to write in memory wherever you want, sure, go ahead, no problem. The opposite is, something very high level, like Lean or maybe Haskell or Camel or even higher level. That you can't compile just anything. You can't, if the inputs and the outputs don't fit, doesn't work. You can create all kinds of really complex patterns that can validate your code, and then the AI comes in and goes like, okay, let me try this. Compiler says nope. And we'll force the AI to iterate until it compiles. And
fuzzy compiling.
Yeah, sort of. You could call it that. You could call it trial and error. You could call it the army of monkeys producing Shakespeare, or. But no, it's actually what Claude does as well, because Claude will run tools for you, and one of the tools it compiles, right? And most of my experience with AI has been with Rust, which is a strongly typed language. It's pretty high level. It could be better, but it's quite all right. So the Rust code that Claude is producing usually works, not necessarily from the first go, but it tries a few times and it's usually okay. And the higher level you go, the harder it is to write a language, but the more confident you are that if it compiled, it is correct, which is very nice. And that's why even in Rust, I'm trying to make our code base as high level as possible, trying to not to sound smart or cool, because I like simplicity, but whenever I can get the type system to do something for me, it should be the type system. It's usually much more powerful than like a code generator or a macro or something like that. So you want to have the type system do the work for you, and then the AI can help a lot, because maybe sometimes the type system, even with the type system, maybe it's messy, and then the AI can come up with a complex solution. But if the type system's good, then you have the confidence that it works, as you expect. So I think they're the yin and yang, right? So good type system, good high-level language features, very strict, very heavy on types, and then you have the AI, which is sort of human creativity compressed and overpowered, and more of it than maybe you have, and more attention than you have, so
it does not get bored or tired so fast as you
Although, if you give it like a really tedious task, as I told you, sometimes it might go off it's not necessarily bored, but it might just lose focus at some point, and not be accurate anymore.
That's
so maybe we'll figure out in a few years that, hey, whenever they're hallucinating, they're tired. Maybe they need some sleep. They need some rest. They need to switch focus, or a new context. Exactly.
Yeah, that's what they need.
I think I read something about some research in like having the AI sort of build their context model and then reinforce it, like as if they were sleeping on it. Reordering their context. And also something that Claude sometimes does is if the context window becomes too big, it can automatically summarize it. So reorganize their thoughts.
That's a very common practice, actually.
Yeah. And maybe that's a bit like sleep, right? Because you put all kinds of information in your brain, and then you go at night and you sleep, and stuff gets reorganized, and chunk gets thrown out, and maybe it's something like that. So.
That's a nice analogy, but actually LLMs work a little different. But
I know, but yeah.
What do you want the next generation of developers, the ones who will be and are already AI native? We've seen so many lately on Telegram groups, and not only. What do you want them to be obsessed with what they currently aren't? Type systems?
Actually type systems, yes. So first off, I'm a bit sorry for them. So everybody who's now in college or finishing college, starting IT, it's going to be a rough few years until we all figure it out, because I don't think any of those jobs are fundamentally or in the long term going away. I think we're going to do a lot more powerful stuff with the people that we have. And I think everybody will find eventually a job. But right now it's a bit of a storm, and nobody knows what they're getting. And we're having to figure this thing out.
Things are settling now.
Yeah, okay. Well, there's also like an aside that some of the companies has used this as an excuse to make layoffs and stuff like that.
Yeah.
So there's also a political side to it, but in principle, yes, everybody should be empowered. It's tricky for juniors because I feel that AI is in many cases better than a junior. So we probably will have to change the way we train people.
Educate them, you
Get
mean?
them, yeah, educate them, get them to be intermediate or seniors faster somehow. Short circuit that because
Or very proficient on using AI tools immediately after finishing university so that they can become very fast productive.
yeah, I don't know how that's gonna turn out to. It's tricky. Yeah, it's tricky. It's tricky because how do you get that experience of failing, right? Of
You know, there's
you do it faster, yeah, with AI, I guess, and
it's
then
distillation. Some and there are articles about Chinese models taking out intelligence and knowledge from bigger models, from American
yeah,
ones.
okay, yeah,
So the student has to do something like that,
yeah.
extracting lots of information and understanding it and becoming like a very powerful user of
Yeah.
the tools that it can build or AI gives
I
them
feel
already.
that I feel a bit that we are fast tracking. There used to be always this path from being a coder to being more like an engineer to being technical lead and then maybe a manager, right? We had that, and maybe some of these people will just fast track into the technical lead or manager position with
And
a horde of AI, right?
Yeah.
I don't know what this does to people if they then hadn't had so much hands-on coding experience, but we'll see. We'll know.
This is a totally different area of
Yeah, it's different, but
thinking.
it's also not so much different because I feel a lot more like a manager when I'm talking to the AI and like producing documents and producing prompts. I'm a lot more like a technical lead handing out specifications to juniors who have to
Yeah.
code it for me, right? So that's one thing, and maybe you can get good at this. Yeah, but I still feel there's a problem that nobody's solving, and I'm hoping that people will start taking it more seriously. Maybe now that we have more time on our hands, time to think, and you don't need to type as much. Yeah, how we make software safe? How do we use better type systems? How do we make better type systems? How do we learn higher level languages? That kind of stuff. I would be very happy for people to do that. Even if they don't use those very high level languages, just to see the patterns, like see, for instance, how data gets represented, how it's optimal to represent data, how is it safe to represent data, There's a very famous adage in functional programming: you should make invalid states unrepresentable, right? A good type system, you should construct a structure that has no invalid states, right? No, like null and an error or something, like error and you shouldn't have both the error accessible and the valid data at the same time, right? That's kind of classical stuff, or shouldn't be able to null pointer reference. It's I was not taught that in school. I learned it
by doing.
By doing up to some extent. But like, if your programming language doesn't do it and nobody else is doing it, you might not figure it out even ever. Like maybe if we start putting that in the curriculum, maybe we have a better chance of making use of the AI instead of being like trampled underfoot by it. Because AI is like a wave. You can ride it or you can totally drown by it. I feel if you can rise to its level and converse with it and give it tasks and be its manager, then you've become very powerful, basically. But if you can't, if just being out, you have a better coder than you that knows how to code a lot better, like the low level stuff, the superficial stuff. If you're superficial, the AI will probably be better than you.
Yeah.
So it will probably force people to be a bit deeper, to go a bit deeper into the concept, into the code, to have a bit of taste, to have a bit of perspective.
And a bit of control.
And the control, and how do you get the control? You need good abstraction. Good abstraction, because oftentimes abstraction is poor, or we call it leaky abstractions, and then it is in the way oftentimes. So having good abstractions, it's not easy, and not even all senior developers, have these really good abstractions. And I feel with these good abstractions, you can then control what your software does, and then you don't have to review every single line of code, because at some point it's also probably going to be a problem.
Yeah.
And then I'm hoping that at some point we're getting better languages, and then the code is much closer to what you want, and then the AI has an easier time translating what you want into code, and then also the whole thing is a lot safer, and then we can have like measurable security, like we can provable security. My dream is that at some point we're gonna have like proving stuff about code will be mainstream and everybody will be doing it. But I'd be happy to at least have it for blockchain for now. Please, guys, please stop misplacing your money or getting it hacked. So at the very least, in like critical areas of programming, I would like that, people are very serious about security and do it well and do it with AI, but at the end have a proof. Yeah.
Andrei, we have to get closer.
Yeah. It's been a lovely an hour and a half or two. I think at this point closer to 2.
There's still one question that I wanted to ask you from the beginning, but I changed my mind and I thought it would be better for the closing part of the podcast. What's a question you wish more people asked you?
Who asked me? Wow. Oh, that's a nice one. Well, somebody asked me recently how they can formulate very fast smart code. It was a nice question to get. I was like, I have something, but I will have to work on it as well.
Do you have 4 hours to talk about it?
I mean, I have talked about it. Yeah, I don't know. How to get started, how to get good, how to get deep into code, I would like that to be asked to me. I don't know if I'd be able to provide the answer, but I'd like to be asked stuff like, how do you write good code? How you got really, really good code? What are your techniques? How,
So going into this direction of advocating or for
better coding. Yeah.
Better.
A lot of the questions you asked me were very nice. I loved getting them. Yeah. How do we write better code? How we write more secure code? How could I learn to be a better programmer? That's actually a question I ask myself all the time.
Yeah, exactly. Now about this, because you are asking yourself good questions, what would be the advice you would give yourself, Andrei from 2018, before, or the one who joined or walked into Elrond in the first day?
There's a big one that I learned in 2019, which is every day I have to choose between the urgent tasks and the important tasks. You have to make time for the important tasks because they will speed up everything. There was, I remember I was saying there was this time when I had to choose every day. Do I work a day on the product that has to be shipped, or a day on the tools that make my life less miserable and make me a faster coder? And I think investing in those tools is the courageous choice. And looking back, it almost always was the correct choice. Whenever I was courageous, whenever I wanted to go deeper, like learn something deeper, learn some more programming, learn some maths, learn something, and go, bring it into the code base and do things smarter. At the time, there was no AI, so the only way you could accelerate your work was if you automated more and make your buttons more high level, make the systems automate as much of the tedious stuff as possible. And like 2018 is still recent. I mean, going back to if I could meet myself from college, I would like, dude, just study functional programming, there's the internet, study stuff like that. Unfortunately, at the time, not only did I not know this stuff, did not even know how it was called. I did not know where to look. I did not even know what to Google for, Now I would Google for, I know, functional programming and
Or
type
ask
theory and
task an AI, give the task to an AI agent and
yeah, there was no AI
argue
then.
with it.
So,
Yeah.
but yeah, and I would spend time learning like advanced stuff because these advanced programming languages and advanced programming concepts, they might seem like they're out of this world and you're not never going to use it, but that's not true. You are using them. And actually, becoming a senior just by having a lot of experience and failing many times works, but it's a very slow path. And I
Yeah.
would like to do the same path faster,
Faster. Yeah.
somehow. If not for me, because I've done this at least for new people in the field, and I would love to be able to explain it to them because I'm not sure I can.
Mm.
I'm not sure I can sort of translate my experience right now into words as easily. I know a few things, but I haven't had time to like really study like really mathematics and really proper and historically complex and very interesting programming models. And I wish I made more time for those things. I wish I'd made more research. I think research is very important. I have to always learn.
Mm.
And sometimes you're tired, and sometimes you spend months like grinding through the low level tedium of every day. You have to do this tool and this tool and this tool and fix bugs and do releases, which is often, you automate what you can, but you can't automate everything. And at some point, it becomes a routine and becomes relaxing. And that's sometimes how you get, you get a ceiling, you get boxed,
Mm.
and you have to get out of the box at some point and start doing some research. I think that's what I would recommend to myself, although it's easier said than done, especially when you're in a startup. And I still tell people that when you're a startup, because I think we are. In a startup, you always have stuff to do that's urgent, and it's hard to just zone out and do research. That never happens, right? So it's a very difficult fight. It's a very upstream fight to learn and become better at it. But I think ultimately you have to do it because otherwise you're gonna stop evolving. And actually, I'm very happy that we have AI because AI can take over some of these tasks and give us hopefully more time to be smarter and better. But we also have to use it like that. So
Yeah.
yeah,
You have to know. You have like a hammer. You have to know how to use
yeah,
it.
yeah. You have to use. I think it was the same with the internet in the beginning.
Yeah.
People. I remember my first time, being on the internet, and I had no idea what to search for. I was like, what now?
What now?
What
Yeah.
now? I searched for some news from NASA and I got a picture of a rocket and like loaded in a few minutes. I was very happy that I got it right the first thing on the internet. I was like, wow. I think the same thing now. We it's not just the AI that has to grow because the AI is growing. The companies that are doing these agents are doing tremendous work, but we also have to grow ourselves to learn how to work with it.
Yeah.
It's not trivial and to ask interesting questions. And that might also be, a purpose of education to show people that some things are possible, at least so that they know they can ask that kind of stuff.
Yeah.
To create the unknown unknowns into known unknowns. Okay, I know this thing exists. I know nothing about it, but at least I know it exists. Versus I don't know it exists.
Yeah, but I think this is a very interesting topic. Even though I know we have to close it.
Yeah, I know.
But imagine that we will have to learn from those new young people who will use AI from a very young age.
Yeah.
And they will think about the entire process of learning and using everything and getting their information out of this huge model and use it in their daily life. Whereas we are already biased because we know the world before AI and we still have to combine, and we are biased to also go the let's say legacy way.
Yeah.
Whereas they will have they see everything different.
Yeah.
Probably they will become more efficient, or probably not.
Yeah, some of them I suppose will. Some of them will get lost in the in the shoggoth, in the tentacles. I think it's similar. We're feeling this with social media now. Like young people are way better with social media than we are, but also it's a dangerous place. You can you get trapped there. Yeah, so it's tricky.
I felt for long that it's dangerous. That's why I closed all most of my social.
Yeah, I know. It's weird. It's weird. And I think this time we the olden ones
The
can help
elder ones.
the elders. Yeah, we can help the young ones. I think we should try to steer them a bit, but then also learn from them. I think it goes both ways.
Yeah.
I think they have a lot to teach us because yes, they will be fresh, and we have to be fresh as well to relearn everything. But then maybe we also have some experience that can help them
We have
find
lots
a
of
way.
battles in the back.
Yeah,
to say so.
yeah, the pain, the pain, you know, and
the
have them
sweat,
find the way because AI is amazing. It's quantitatively you do so much more with it, but qualitatively, I don't think AI right now does anything that a human could not do given enough time.
Yeah,
right?
Exactly. That's a great
So
way to put it.
given enough time or enough humans, like a team that's infinitely large, infinite time, I don't think AI can do anything that we couldn't, in principle at least.
Andrei,
Yes,
this was great.
absolutely.
Where should people follow you?
So I'm on Twitter, X on Twitter,
X,
Andrei
yeah.
and Marinic on X. I'm on Telegram. I'm on the developers Telegram. Yeah, that's pretty much it. Try to keep it minimal.
And very short, what should they expect from you, or what should they expect next? What should they look at in the next 2 weeks, I would say?
We're gonna have a release soon. I'm going to redesign some of the framework. What stuff? Next 2 weeks.
No breaking changes.
No, we avoid breaking changes usually. We're very careful. We're very nice with that. And yeah, so next 2-3 weeks, I think it's gonna be a release, some new tooling, reproducible builds. I'm gonna play around with web stuff. That's what I want to do. Finally, time for me to learn some web, or at least vibe it. Yeah, I think that's been long coming, and there's also going to be a course that. Like the course itself will not be public, but after the course will be done, I think the course will become public and everybody will be able to watch it. I think in like 2 months or so.
Okay.
That's
nice.
gonna be something
for the
that
Spanish
the
initiative.
the blockchain school. So that's I think gonna be pretty nice.
Very nice.
And it's going to force me to structure what I know and what I've built in a way that is digestible by beginners.
Typified.
No. I mean, maybe, sure, but the point is for people to build stuff. And actually, we shouldn't forget that this is the ultimate goal is for people to build cool stuff. That's why we have software for, and everything else derives from that. So you can have the best technology and you can have the safest technology. Still, people need to use it for it to be relevant and important, and that's the most important thing, that people have fun and should code stuff.
Any closing words?
Yeah, it's time to build the classical. It's time to build, and yes, I want everybody to enjoy this period where we're all discovering AI. I think it's a cool time to be alive, and we should be curious and think with it with fresh eyes and fresh hands, and try to learn and discover and try to understand things as deeply as possible and build cool things and have fun. And also take care of your health and mental health and go for a walk and touch some grass.
Touch some
yeah,
grass,
we're because we've been talking for 2 hours about coding, and which is mostly sitting in a dark cave in front of this device.
Close the lights,
yeah, it's good. It's very, very important to also be humans and interact with one another and touch grass and meet people and have fun and go for a beer. So yeah. Tomorrow is International Labor's Day, so a lot of fun eating meat and drinking beer. I think
with mustard.
It's a great time to reconnect and be human. Yeah.
Andrei, once again, thank you very much. It was great. Definitely, we should repeat it or continue the discussion.
Yeah.
And for everyone back home, thank you very much for joining us once again. See you next month with the same energy and the same momentum podcast. Thank you very much.